Alrighty, so hello Year 10s, welcome back to our science lessons. This is just a little video to accompany our third lesson on ionic bonding. So I just wanted to give you a bit of a recap before you got into it and got started on what that word ionic means or where the name of this type of bonding comes from. Activity 1, Activity 2, Activity 3, all of these activities that you will work through give you a really comprehensive overview of this process of ionic bonding, but I just wanted to include this additional little video as a bit of a consolidation perhaps for you at the end. It could also act as a nice little introduction to the topic. So whenever you choose to view this, that's very much up to you. So ionic bonding are bonds that occur between a non-metal and a metal on our periodic table. So remember that the metals live over this left-hand side of the periodic table, so sort of in that region. The remaining over on the other side here are our non-metals. We have a pairing between these two groups in our ionic bonds. Breaking down that word ionic, the first three letters there form that word ion. Now I'm sure this word is familiar for you from your junior sciences and from perhaps previous knowledge that you have, but an ion basically is a charged molecule. We know that we can have things that are charged that are either positive or negatively charged. So an ion is a charged molecule. So we know that it can be positive or negative. How do we get a charged ion? So this is an important part of this process. To fully understand that, we have to hark back to that knowledge that we reviewed in our last few lessons. So when we were talking about a review of atomic structure, and let's think about electron shells for a moment. So remember that ideally, an element would love to have its outer electron shell full. When that is the case, it's a happy element. So if you look over to the right-hand side of our column there, these guys, helium, neon, argon, krypton, etc., xenon, these elements have a full outer shell. They're happy. They're very content where they are. Happy as Larry. These guys, as another little example for you, so fluorine, chlorine, bromine, iodine, they are just one little electron away from having a full outer shell. They're one little electron away from being happy. So they are very, very reactive. On the contrary, if we have a look on our left-hand side of our periodic table, so our hydrogen, our lithium, our sodium, our potassium, part of our metal group here, they have one lonely electron in their outer shell. So they've got one little electron that if they could get rid of, they would then have a full outer shell. And we can see that process just in our diagram underneath here. So you can see there our sodium atom. Our sodium atom has how many electrons, how many protons? Well, let's have a look at the atomic number. So our sodium atom has 11 as its atomic number, or its atomic number is 11. That tells us that it has 11 protons and it has 11 electrons. When it has that, so when it has 11 protons with a positive charge and 11 electrons with a negative charge, it's balanced now. So those positive charges are cancelling out those negatives. And we can see the electrons in the electron shells in that diagram on the left. But for the sodium to be happy, it very easily can use, or lose I should say, this little lone electron there in that outer shell. When it gets rid of that, there's a shift from 11 protons to, oopsie daisy, 10 electrons. We cancel that out, we're actually left with a charge, a positive charge of 1 positive, which is reflected in this little label here. So it says sodium plus. So a sodium ion, it's positively charged. Because it's lost one electron, it's now left with a positive charge of 1. All right, that's half the story. We mentioned before that metals, so our sodium here is a metal. In ionic bonding, it bonds with a nonmetal. So remember that our nonmetals live over the other side here of our periodic table. I'm going to give you 3 seconds to guess the element that we are going to be working with next. What's a common compound? Sodium, what? What could we be going for here? It lives on your kitchen table for the better part of its life. Sodium chloride. Yay, fun fact. Good job, everyone. Sodium chloride is a very common compound, and we're now going to look at how these two elements ionically bond together. So chlorine lives on the other side of our periodic table. It needs to gain 1 electron to be happy and to be content. Guess where it gains that electron? Bada bing, bada boom, from our sodium atom. So our sodium atom here is quite happy to donate its little extra electron to a chlorine atom. The chlorine atom that needs 1 more electron to be happy and full. So let me scroll. What you end up with is a sodium atom that's positively charged. Our chlorine atom, once it gains this little lonely electron, it's now got, let's have a look what the atomic number of chlorine was. 17. If it gains 1 more electron, then it's got 18 electrons, but it still has 17 protons. So 18 electrons, that's not an 8. 17 protons, cancel, we're left with a negative charge of 1. So we have a sodium ion, or a cation because it's positive, pairing with a negatively charged chlorine ion, which is known as an anion. That's how they live. That is it. A tiny introduction there. I am quite sure that the additional resources in here will be more than enough to solidify your understanding of this, but of course ask any questions in our Teams page. I just thought that would be a nice little introduction, a little bit of a recap of some of the content that we need to know. Well done. One last thing. Damn, I really thought I had a fun video of a monkey. Next time. Have a lovely day.